Good morning, everyone. Thank you for your nice presentation. I'm Giovanni De Francesco. I'm coming from Italy. I'm working on beer and malting science for more than 15 years. And today I will share with you one of the last studies that we performed on beer production. We studied the effect of yeast strain and pasteurization on low alcohol beer quality properties. So today at the beginning we will dive in technical production of low alcohol beer, and then I will show the results of our experiment. But first of all, I want to say thanks to all our team. We are working all together. It's a team that now is composed by 14 people. We are colleagues almost for 10 years. So it's a very expert team. And these 14 members is composed by university professors, research fellows, PhD students, and skilled technicians. Because our brewing research center is a part of the University of Perugia. So we have the mission that you can find in all universities. So first of all, we are making research, scientific research. And in this picture, you can see our pilot plant. It's a pilot plant for the production of wort and beer. And is a pilot plant that is a small copy of industrial brewing plant. So there are all steps for the production of wort separated. This was established 22 years ago by a large industry engineer. And so normally in a craft beer, you cannot find this type of plant. In our plant, we can find a small copy of industrial plant. And these 30 years, we published more than 70 scientific papers on malting and brewing, all published in international peer-reviewed journals. Also, we are performing training for brewery, for microbrewery, for micro-malting. And as you know, in the world, there was a craft beer revolution lasted 20 years. And also in Italy, we saw a huge expanding of this field with more than 1,000 microbreweries now that are open in Italy. So there was a very beer revolution. And in this, we trained over than 1,000 students, as some of them now are brewers in Italy, and some of them also out of Italy. Also, we are performing analysis on the wort, on beer, on raw materials like barley, yeast, hop, and water. And also, we are performing consulting in malting and brewing all across Italy. So we have less people, but we have a lot to do. And also in this picture, yeah, you can see in this part and in this part of the plant, this is the part of cleaning that I will talk about this in the next slides. And the cleaning of a plant is very, very fundamental in the brewing process, especially in craft beer that is an unpasteurized beer. So the tanks must be as clean as possible to avoid the microorganisms arising that are detrimental for beer, like lactic bacteria or wild yeasts that detriment the taste and the aroma of beers. So the cleaning part of the brewing industry is a very important part. But let's have a look on low alcohol beer situation in the world. As you can see sometimes on journal news, last years something is changing. The new generation, millennial, Gen Z, are super curious, they like moderation. So more and more people reduce their alcohol intake or abstain completely for health reasons. This is completely new respect than the past. In the past, alcohol was on the table every day. Now people are changing. Also, awareness of the negative effect of alcohols. Now there are also political push on this aspect. And sometimes, for example, I put this example of a label, there is some political that are proposing to push on the bottle, on the label, information like tobacco, like health warning. For example, the Irish government started to use this kind of information on the label, but in Italy is still not indicated this aspect. Potential health benefits. Some studies suggest that low alcohol, non-alcoholic beer may offer benefits such as better sleep, reducing stress, and rehydration. Also, drinking and driving is a new topic. Last 5 to 10 years, the police, the government are getting more and more pressure on this aspect. So it's important to find some solutions. Alcohol-free beer would be one. Innovation in brewing techniques. This is one of the most important aspects. Today we saw this aspect. The brewing industries have invested heavily in technology. So now the alcohol-free beers, the low alcohol beers that you can find on the market are much better than the samples that you find, for example, 10 years ago. So the taste is much improved. Sometimes are very similar to normal beer, and this obviously helps to increase the market volume. And also the adults are cutting back their alcohol consumption. The Nielsen survey found that 47% of adults cutting back. Also, we can see that, for example, Germany, that is leading now in Europe with 20% of total sale, registered up 109% of increase in sales last 10 years. And if we look at normal beer, it's completely opposite. In Germany, maybe now we are less 35% respect than 10 years ago, 20 years ago. And also companies are promoting alcohol-free beer at sport events as natural alternative to energy drink. So something is changing. And anyway, when we talk about low alcohol beer, we must know that this product is different between countries. In Italy, for example, in French, the alcohol-free beer is a beer with less than 1.2 alcohol % volume. In other countries like UK, alcohol-free beer is a product with 0.05% of alcohol. So it's completely without alcohol. And in US, for example, also alcohol-free beer is 0. Then there is low alcohol beer that is between 0 and 0.5, and then regular beer. So any countries has a different regulation. Normally in Europe, most countries have 1.2% of alcohol in as a limit. And now just a look on the most important technique to produce low alcohol beer. We have biological technique and physical technique. And today just we have a look to understand the difference of this kind of technologies. The first that we will see is a vacuum distillation. This is a technology that is very, very common today in the brewing industries. Maybe in the large beer industries is the most important process that they are using to produce alcohol-free beer. Why? Because for the first, this technique can remove completely alcohol. And we are seeing on the market that the beer with zero alcohol are the most attractive for the consumers because they don't want absolutely alcohol. And also some place that have religious meaning that you cannot drink alcohol. So most large industries are aiming at zero, completely zero alcohol. And with this technology, it's possible. Vacuum distillation is a technology that can remove alcohol at low temperature than normal distillation to produce gin and other similar distilling product. In this case, the process is running at 38 to 42 degrees, thanks to the vacuum. So there is a low thermal stress of beer, and also is a process very fast, some seconds to remove alcohol. And normally the large industries, so they are producing a normal beer, 5 alcohol percent of beer, and then they remove alcohol. So we have color in beer because we have a lot of malt. We have foam in beer because we start from normal beer. And for this reason, this product is quite similar to a normal beer. Anyway, as you can imagine, with this vacuum distillation, we can remove alcohol, but we also remove other volatile compounds that are very important for the aroma and for the taste of beer, such as esters, higher alcohol, aldehydes. So the profile of beer is completely empty at the end of this process. So it is necessary to add back flavoring. Then the beer must be diluted after treatment. Then beer must be carbonated because the carbon dioxide is completely removed during the alcoholization. And then pasteurization is required. So as you can understand, it is not a simple process. And the plant is very, very high in costs. So this investment is now, today, is almost reserved or sold only for large beer company. Then there is a reverse osmosis that is a process a little bit simpler than the previous. It's useful for beers with a very low alcohol content. It is possible to produce 0.05% of alcohol easily. It is a cold process, so the alcoholization is around 20 degrees. And also there is a relative simple plant engineering. Anyway, high running costs about energy. Reverse osmosis is impactful in energy. Carbonation is necessary. Excessive loss of volatile compound, as I said previously. And sometimes there is the process of high water consumption. As I said before, for the reverse osmosis is necessary pasteurization, like vacuum distillation. Then there is osmotic distillation. It's a relatively new technology. I worked on this technology for some years during my PhD experience. It's a process that uses semi-permeable membranes that is able to remove ethanol from beer, and the ethanol moves from beer to the water. So you have a membrane, and one side of the membrane there is beer, in the other side there is water, and the alcohol moves from from beer to water. But obviously not only alcohol, also aldehyde esters and so on and so on. So the beer at the end of the alcoholization must be flavored with some, otherwise the taste and flavor is empty. Also in this case, carbonation is required. Excessive water consumption, this is a drawback. When I made experiments some years ago, we used 6 liters of water for each liter of beer to dealcoholize it. And again, pasteurization is required. As you can see, in any technologies, the pasteurization is required. Why? Because there are some studies, there are some recent studies that highlighted that in a low alcohol beer can grow also pathogen. In normal beer, it is not possible to find pathogens. In low alcohol beer, yes, it is possible. So pasteurization is strictly necessary for this reason. And also, pH management is very important. We will see later. Except for physical technology, there are also biological technologies that are simpler, sometimes are easy to manage for small craft beers. So sometimes you can find products on the market that are produced with this technique, with this technology, and usually are produced for craft beer, craft breweries. For example, interrupt fermentation is the only biological method of producing alcohol-free beer with less than 0.05 alcohol percent. It's relatively simple to manage because you need just fermenter, wort, yeast, and a very, very short fermentation, some hours of fermentation, just a very, very few metabolites from fermentation. Then you stop the fermentation, cooling down the beer. In this way, the yeast is not able to ferment, and then you need to remove the yeast by filtration, and then you need to stabilize beer by pasteurization. In this case, as I wrote, the pH management is crucial, because without fermentation, there is no dropping of pH, because the dropping of pH is due by yeast during fermentation. But if there is no fermentation, there is no pH drop. So sometimes this beer has a pH more than 4.6. That is too risky for the botulinum. Okay, so it's very important to manage pH in this kind of beers. High temperature meshing is another technology for to produce a low alcohol beer. The wort is the meshing. The wort is produced at high temperature. In this case, you avoid the activity of beta amylase, that are enzymes that produce maltose, that is a fermentable sugar. So we avoid these enzymes work just going at higher temperature than optimal for this enzyme. So we have sugars, but a very low amount of fermentable sugars. But anyway, again, the pH management is crucial. The pasteurization is required. In our work, we used a combination of high temperature meshing with negative maltose yeasts that are yeast able to ferment just sucrose, just glucose, but they are not able to ferment maltose. That is the main sugars in the world. So at the end of fermentation, we have a low amount of ethanol. And then also we use the innovative hop extracts to increase the flavor of beer, because as I said before, this kind of beers have a lack of volatile profile, have a lack of intensity in the nose and taste. And then at the end, we evaluate the influence of pasteurization on the quality characteristics of this kind of beers. The beer was produced according to the following recipe. So sugar beginning of fermentation, original Plato degree, where 6, that is very low amount. Normally in a normal beer is 12, this value. In this case 6, so we wish a low amount of fermentable sugar. Bitterness 10, very low amount. If you know India, Pale Ale, for example, a very famous kind of beer. In that case, the IBU, the bitterness, is up to 40, 50 sometimes. So in this case, we want a very low amount of bitterness, because otherwise this kind of beer can be too bitter at the taste. And then we produce this with a mash at a temperature, as I said before, so machine at 75 degrees, when normally in the beer industry is 52 degrees. So it's a completely different temperature, special machine for this kind of beer. And then we made the rest at 75 degrees for 30 minutes, and then the rest at 78 degrees for 5 minutes. Boiling for 60 minutes as a normal wort production schedule. And then the pH was brought to 4.53 with the addition of lactic acid. Then the beer was fermented with these yeasts, conventional yeasts that are unable to use maltose for 4 days. So a short fermentation, and then the temperature was cooling down at 0 degrees for 5 days. Then we removed yeast. The pH was further lowered to 4.3 with the addition of lactic acid, and then the beer was filtered with a polypropylene cartridge to remove yeasts, to remove other colloids from that were occurred during fermentation. And then after filtration, the 2 samples were separated, and in samples we add Hyperboost, Yakima Chief, Cedar, and Mosaic that are hop extract, high concentrated. It's an innovative hop extract that is sold for some months on the market. And you can see just some microliter per liter of beer are able to improve, able to increase the flavor profile of beer. And this kind of product are developed especially for the correction, for the increasing of aroma directly on filtered stabilized beer. So just before the bottling. Then we carbonated beer up to 5 gram/liter of CO2. That is an amount that is necessary for the foam formation, for the good tasting of beer. And then we bottle the beer in isobaric condition, and then we perform analysis. The 2 yeasts that we used in this experimental work were from the market. One is from Fermentis company. The second one is from Lalleman. That are 2 companies that are producing yeast for brewing. And one is called the LA01, and the second is Luna. So we, at the end of experimental design, we had 8 samples, 4 samples unpasteurized, and 4 samples pasteurized. And between unpasteurized, we had a sample without hop, a sample with hop at the end of filtration before the bottling. So we had 8 samples. We perform a normal analysis, volatile compound analysis, and aroma and taste analysis by sensory panel. All the analyses that we performed are according to analytic ABC, that are the guidelines for the European Brewery Convention. And so we follow with this method. We checked original apparent and real extract, alcohol by volume, apparent attenuation and real attenuation, pH, color of beer, bitter intensity, age, turbidity, foam stability by Liebman method that check how many seconds there is foam on beer. So the unit measurement is second. And then the sensory analysis by trained panel. Let's have a look on the results. Here, the most important things when we talk about low alcohol beer, the alcohol content. And as you can see, the alcohol level was much similar between samples. We reached the aim. We wish an alcohol maximum 0.5. In this case, the alcohol was 0.06 sometimes, but normally 0.5. And so for the Italian government, this is a low alcohol beer, alcohol-free beer. And the original degree Plato in this table, as you can see, was 6, very low amount, but this was our aim. In that way, we would not a lot of alcohol at the end of fermentation. And in blue histogram, you can see unpasteurized beer. In orange histogram, you can see the pasteurized beer. Obviously, pasteurization did not influence the alcohol content of beer. Then we measured the pH and the bitterness. pH, as I said, is very important for this kind of product. The pH was stable and was similar between samples, as you can see, was 4.3. And bitterness was a little bit higher than the schedule that we wish that the bitter was 10. At the end of the analysis was 20. So the bitter perception is a little bit higher than expected. But this can be correct with the new recipe without problem. Again, as you can see, the pasteurization did not influence both pH and bitter of beers that were similar before and after pasteurization. Then foam quality is a very important beer quality parameters, especially for low alcohol beer. That is usually one of the most important drawbacks of this kind of beer, the problem of the foam. So we measured this aspect, and as you can see, pasteurization did not affect the foam, but for the samples without help, especially this kind of beer, we registered a very low amount of foam. Normally, a good foam stability is more than 200 seconds. In our samples, the maximum was 180, 178, 173. So a little bit lower than the optimal for beer. And so we need to work on this aspect for the next experiments. And also for in this case, for example, with the LO yeast, the foam was very low. So about foam, LA yeast works better than LO in our experiments. Then another quality aspect of beer is the turbidity, the age. Normally, beer on the market is brilliant, is clear. So we checked these parameters, and we also saw that it's not so simple to get good turbidity, and we filtered and then pasteurized beer. Unexpected, because we were thinking that pasteurization was detrimental for the AIDS. In our case, no. For 3 beer out of 4, the pasteurization caused an improvement in food stability, in AIDS, maybe because during pasteurization there was some colloids formation, and then these colloids precipitated on the bottom of the bottle. One sample, on the contrary, the LOP, after pasteurization, there was an increase on AIDS. Then sensory analysis. Okay. Sensory analysis. This is the aroma profile of beer, so the olfactory part of beer. And as expected, we obtained good fruity citrus profile when we had hope before bottling. And pasteurization caused the reducing of aroma intensity. This was expected, but we were happy because after pasteurization, there was still perceptible smell in the nose. So, okay, pasteurization caused a decreasing of intensity, but not disappearing completely of fruity citrus. And this was a positive result. A negative aspect of a low alcohol beer is of flavor that is called wort. Is a smell, is a fault of a low alcohol beer that you can smell as similar cooked tomato flavor, also some vegetables, cooked vegetable in the nose, so it's not really enjoyable, but it's a problem in this kind of beer, and that this is one of the reasons that we added hope extract, just because we aim to mask this flavor with the addiction but you can see the panel found this off flavor even when the hope was added. In this sample there was hope. In this sample there was hope with dry hopping. We still found this off flavor in beer. If we look at taste profile, so in the mouth when we taste beer, we found fruity citrus, very positive aspect, and also we found this fruity citrus character after pasteurization in all samples, but obviously especially when the hop hop extract were added. Still, as a factory profile, we found this cereal worthy of flavor in unpasteurized and pasteurized beer. And also we smell acid and astringent, especially acid. Also this is expected in this kind of beer because removing alcohol or with low amount of alcohol, we have a little bit too high acidity. So we tried to equilibrate this with the sugar. Okay. And then one important aspect was drinkability. This is a parameter very important. We found nice drinkability of this beer, especially the beer with the LA yeast. We found 7, for example, in this case, on a scale from 0 to 9, so was high drinkability beer. And this is a very positive result. So in conclusion, We confirm that Saccharomyces species available on the market are suitable to produce non-alcoholic beer. The combination of high temperature meshing and the use of maltose negative yeast represents a viable strategy for small-scale breweries. The addition of aromatic hop extract enhances the sensory profile of non-alcoholic beer. Buffy strains exhibit similar fermentation behavior. Pasteurization reduces the aromatic intensity of beer, particularly the citrus notes from the hops. And despite altering the beer's aroma, pasteurization proves to be highly beneficial, offering several advantages to producers, especially in terms of microbiological stability of beers. Thank you for your attention.